So let's pick back up again with the next part of Unit 5 exam review. I'm going to do 3, 4, and 9 in this video. So I'm just using the rest of the paper that I was using previously. So here's number 3. 15 square root 60x to the 6th all over 9 square root 12x. Now, anytime you're dealing with fractions and radicals, I recommend rewriting this as 15 over 9 square root 60x to the 6th over 12x. If you've got the same radical, just divide what's put inside both of the same radical. You don't need to write two separate ones. You can put it all together underneath one large, tall radical. So 15 over 9, let's go ahead and reduce this coefficient first. They both reduce by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. So my new coefficient is 5 over 3. And then let's reduce what's inside the square root. 60 divided by 12 is 5. X to the 6th divided by x, well, it leaves you with just 5x to the 5th. All right, so that's nice and convenient, x to the 5th. Now, when we look at this, the only thing that's left to do is to find groups of size 2. Can't do that with the 5, but you can do that with the x to the 5th. So we'll have 5/3 x to the 5th. Let's see, 1, 2, 3, 4, 5. 2 groups of size 2 with 1 left over. X squared square root 5x. You can include all that in the numerator and you're done. Okay, so really all that you did here is you simplified the coefficients in the front, simplified the insides of the radicals, the radicands, and then you found groups of size 2 to bring out of that square root. So that's number 3. Let's look at number 4. Number 4 is another simplification, this time with multiplication. Cube root of 9 times cube root negative 24 minus cube root of 2. Now, here's the catch. You guys follow PEMDAS here, which means you got to do your multiplication first. So cube root, they're both the same cube root, so you can multiply their insides. I'm going to rewrite this though. 9 is 3 times 3. 24 is 3 times 8. And I'm going to take that negative and just put the negative on the outside. That's the nice thing about odd roots, third roots, fifth roots, seventh root. Odd roots, you can take the negative and just put it on the outside. Even roots, different story. And then there's still minus the cube root of 2 chilling as our last friend to deal with. Now, the cube root means I'm looking for groups of size 3. Well, hello, there's a group of size 3. That's why I broke my numbers down. So I've got negative 3, and then hopefully we know the cube root of 8 is 2. If you don't know that, double check it. 8 is 2 times 2 times 2. So group of 3 2s, done. And then we still have minus cube root of 2 chilling on the outside. And my final answer is negative 6 minus the cube root of 2. I can't do anything else. That's it. So PEMDAS multiplied first. And then I considered subtraction, but since they were not like terms, I had nothing to subtract. All right, last one in this video is number 9. It is another multiplication problem. Cube root, again, negative 9x squared y to the 5th times cube root 21xy squared. So multiplication, cube roots, I'm just going to do a couple of things here. I'm going to take the negative out first, and then I'm going to write this all together, but with my numbers broken down. The 9, I'm going to write as 3 times 3. 21, I'm going to write as 3 times 7. And then I'm going to combine my x's. So x squared and x is x cubed. Y5 and y squared is y7. When you multiply the same base, remember you're adding those exponents. So it's 2 plus 1, 5 plus 2. All right, group of 3. There's one group of 3. There's another group of 3. And then y to the 7th, that's going to have 2 groups of 3 with one y left over. So negative 3x y squared cube root 7y. Right? 1, 2. So out, 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 left over, left over. And there's our second video for Unit 5. Last one, we'll have 5, 7, and 8.